environmental focus in this CRC has been really important, and particularly so in the sense that biological assets and water resources have been particular outcomes that have been sought by the CRC, and they haven't just been add-ons to production systems. The three key objectives for the Biodiversity and Water program were firstly to see if increasing perennial vegetation in the landscape provided habitat for native fauna. And secondly, and perhaps most importantly, we're interested to see if increasing perennial vegetation in the landscape enabled us to better manage the water cycle to protect water resources and biological assets. And thirdly, we undertook research and analysis to make sure that any new plants that we were bringing into the landscape or bringing into the country didn't represent an environmental risk in terms of, say, weed or genetic risk.
Well, BioRisk, I guess, was bringing together a new planning framework. What we're doing here is we're trying to protect Lake Toolabin from turning into Lake Tarblin and becoming more or less a saline dust bowl because of the impacts of altered hydrology, extra water coming into the lake and rising groundwater. We've seen salinisation of many of these systems because of land clearing. Toolabin Lake's very important because it's the last freshwater wetland with a wooded lakebed floor that's in relatively good condition in the West Australian wheatbelt. The lake is also important because it's Ramsar listed, which basically means it's an area where there's a large number of water birds that come here during lake fill events. Effectively what we did was artificially create a lake inflow event or a lake filling event for just this area by holding water in this bund for about 2 weeks. And we measured the plant responses to that increased moisture availability in the subsurface, as well as what happened with the rising groundwater levels. The research brought together elements of plant ecophysiology, planting processes, and hydrological modelling to try and look at the relative benefit of diverting surface water around the lake and stopping it from flowing into the lake, as well as lowering groundwater levels in the lake using groundwater pumping. There's many parts of a catchment where planting trees may not have the benefit that you expect it will, so it's really important that you understand the hydrology and assess the benefit of planting trees in different parts of the landscape or using CRC farming systems in different parts of the landscape to make sure you get the best outcomes for your biodiversity assets.
In achieving our objectives, we've done a number of things, but one of the interesting components of our work has been the development of new decision tools. For example, one of the components of BioRisk has included developing a new planning framework, and also, of course, the INFFER program has been very important.
So INFFER arose from a need that we recognised to help environmental organisations do a better job of evaluating and prioritising their environmental projects. From our work that we'd done with a variety of environmental organisations, we could see that this was a really challenging task because it requires people to combine together information about technical things, environmental things, social things, economic things, and that's really quite challenging. So we tried to develop a tool that would do that in a simple way and give them advice about value for money from investment in environmental projects. So that's why we called it the Investment Framework for Environmental Resources.
INFFER is very simple at its core. It's really about understanding what it is you're trying to protect, to what extent those values are at threat, and most importantly, can you actually feasibly intervene to manage the threat? If you take the case of the Malort wetlands, there's about 1,000 hectares of wetland habitat here in this area. It's in a very highly modified agricultural landscape, and what this provides is a biodiversity hotspot in the landscape. And of those 1,000 hectares, we've resolved that we've been able to intervene to protect about 380 hectares. We were at a stage in our cycle where we were questioning some of the investments that were being made, and we had a good hard look at some of our investments, and we really questioned whether in fact they were going to achieve the stated benefits of the business cases. And some of the leaps of faith that were taken from what was proposed as an intervention to what the outcome would be, they really were not credible.
Over time, we know it's been successful because we can see how many users we're getting. There are a lot of users now around Australia, and increasingly we're getting users in other countries as well.
It's superior to anything else I've seen, and it's had a profound impact on our organisation and the way we think about investing in the environment. The only things that governments are going to invest in is very credible business cases that are well considered, that have community support, that are based on strong science. And what INFFER and the tools associated with INFFER give us is the ability to produce that credible business case, and that really does position you well in a very tough fight for funding.
I think there have been real key legacies from the environmental program. The first of these, that we've certainly greatly increased our understanding of how to manage water at landscape scales to better protect biological assets and water resources.
Productivity on our poorer land was very bad. We were getting about 2 sheep per hectare grazing on an annual basis. Our good land was already doing about district average, 3.5. So we thought the best productivity gain would be on our salt land. We looked at it from a positive point of view, saying, well, the salt was here before the land was cleared, so we actually haven't got a salt problem. We've got too much water. This area here, it gives us a good overview of what our system is. In the background, we can see a line of trees. The idea is to cut the water off coming down off the high ground. Then on my right, behind me here, we've got perennial pasture, so the water that gets past the trees then gets used up by the perennials. Left behind me is an area that used to be very shallow water table, going saline with bare scald. The water table at 1/2 metre. The water table is now 2.5 metres, and as you can see, the scald's gone. In front of me, we've got an oak crop that will go about 4 tonne, simply because we've used up the excess water before it's got there to create inundation. Our system is putting perennials in and grazing them to the maximum, getting the maximum production out of them, which means we have to replace them fairly regularly. We don't look after them, they're not mollycoddled at all, so we've been able to carry on our salt land, or our waterlogged country I prefer to call it, similar carrying capacity to what we have on our better pastures. The CRC has been a great thing because CRC has actually been going back for 14 years now, so we've had 14 years or more of research, of collaboration by farmers, researchers, ag departments, all those sort of people coming together to get packages that'll actually work on salt land. And some of the great things that have come out has been like the Messina, getting legumes into our salt land, which has been almost the holy grail, if you like. Things like Tetera, and it's sort of backed up what we've been doing, and known anecdotally, good figures coming out to say that this stuff actually works and it's a dollar value. We have to try and replicate nature, or else we're doomed to fail down the track somewhere along the line. So by planting trees in the right spot, we're not losing production, we're actually helping with biodiversity, using water on our salt land. We're actually getting soil microbial activity back into the ground, all this sort of stuff. And that all adds to the mix of working with nature and not against it.
The challenge going forward is to take the work that we've done to date and turn it into serious management actions which continue to deliver the outcomes for the biological assets and water resources of our nation.